In this video, we're going to use integration by parts, but we're going to consider it with a definite integral. So when we take our integration by parts formula and we combine it with the second portion of our fundamental theorem of calculus, we can develop the formula you see here on the screen. So the integral from a to b of u v prime is u times v, we would evaluate that between b and a, minus the integral with the same bounds, b and a, v u prime. So let's do an example. In this example, we're going to find the area of the region bounded by the given curve and the x-axis on our interval that's given from 0 to 4. So as we look at integrating and finding the area between a curve and the axis, it's always important to graph the function. So the function we're dealing with is x times e to the negative x, and I plug that into my y equals on my calculator. I get a graph that follows this curve. Now, we are only interested in what is happening between 0 and 4, which means we cut that region off, and we want to find the area of this shaded region. It's always important to look at the graph, so you should always, pull your graphing calculator out, get an idea of the space you're looking at on the screen. And you may have to change your window in order to get a good view. Notice my y-axis is being measured significantly different than my x-axis. That's only going up to 0.5 or 1/2 right there. And one of the main things that we're looking for, especially when we are dealing with these area problems, is there an x-intercept, or if we had multiple curves, which one's above and below versus left and right. So the area, when we set up our integral that we want to calculate here, is going to be the integral from 0 to 4, because that's our interval, of my function x e to the negative x dx. So now that we understand what we're looking at and the shape of the region we want to integrate to find the area of, and we've set up our integral, this is pretty easy integration by parts stuff. So I'm going to let my u will equal x, and then v prime is e to the negative x. So I want you to keep in mind, again, when you're trying to decide how to do that, the way we often choose, but not always, is we use Liate. And x is algebraic, e to the x is exponential. So algebraic comes first. That's what I use to choose my u value, my algebraic expression. So u prime, the derivative of u, will be 1, and v is going to be negative e to the negative x. And this negative in the front is coming from the fact that we had a negative in the exponent. We actually do a u substitution to integrate v prime and get v. So as we move along and set this up, this integral is going to be uv, which is negative x e to the negative x. We'll need to evaluate that between 4 and 0, minus the integral from 0 to 4 of vu prime. And u prime, you'll notice, is 1. So when I don't need to write that there. So I've got negative e to the negative x dx. So, I can go ahead and evaluate this now, but I'm just going to leave that until I have my second integral completed here, because that's going to, I can just evaluate it all at once. So let me clean this up. I've got negative x e to the negative x evaluated from 0 to 4. These two negatives become a plus, the integral from 0 to 4 of e to the negative x dx. And again, that piece, integrating e to the negative x, gives us negative e to the negative x. So now I have negative x e to the negative x plus, and the integral of that is negative e to the negative x and that would need to be evaluated between 4 and 0. So like I said, I could have plugged my 4 in and my 0 in up here, but once I integrate this, I can just evaluate the whole thing between 4 and 0. So plus a minus, that's going to be minus there. Negative x, e to the negative x, minus e to the negative x, evaluated between 4 and 0. So I'll plug in 4. I've got negative 4, e to the negative 4, minus e to the negative 4, minus 0, e to the negative 0, minus e to the negative 0. So negative 4, e to the negative 4, minus e to the negative 4. 0 times anything, that goes to 0, and anything to the 0th power is going to be 1. So I end up with minus, well, that would be minus 1, so I have plus 1 here. All right, because I had minus negative 1, that's plus 1. And we can simplify this a little bit since these are like terms. I can say, well, I have negative 5 e to the negative 4 plus 1. That would be my final exact answer. If I wanted to, I could plug it into my calculator and get an approximate value, about 0.91. So just to recap, in this video, we did a integration by parts with a definite integral. So if you have any questions, as always, please send me an email.